Welcome back at JakajimaTV. Today we're going to talk about 3D printing electronics. And we're going to do this with Martin Hedges. He's the founder of Neotech, and he is one of the first companies developing 3D printing electronics. So Martin, welcome at the JakajimaTV interview. Let's start immediately. So could you give an introduction about your company and what you're actually working on?
Okay, thank you very much, Peter. Good. So what I'd like to do is just very quickly run through Neotech AMT Gmbh, who we are, what we do. So as Peter said, we are involved in 3D print electronics. We're a machine tool manufacturer, so we specialize in this field. It's all that we do. So we make equipment for printing electronics in 3D. We've been pioneering this since 2009. We built probably what was one of the first commercial systems worldwide in 2010. And we always had the intention of wanting to scale these technologies to be able to use them in mass production. So we built this 45X system in 2012, which is a patented system. And what that stands for, the 4 stands for 4 printheads working in parallel, 4 tools working in parallel, so you can produce multiple parts at once. And 5-axis, because we work with 5-axis range of motion, that allows us to get the free form build, so the full 3D capabilities out of the system. We were lucky enough to have the first success with this system in 2013. So we had a client in China that took one of these 45X systems for product development, and they actually then ran some mass production from 2015 to the end of 2017 in the cell phone field, so printing millions of parts per year. So what they're doing is actually effectively printing circuitry, sensors, and antenna onto cell phone housings. And then last year we were lucky enough to win the German TÜV Innovation Prize in combination with a research partner, the University of Erlangen-Nuremberg FABS. Good. So what we do, basically we print electronics in 3D space, and there are 2 ways to work. The first is we started on initially, we have standard components, so you take an injection molded part, or it could be a composite component, or forging or casting, it doesn't really matter. So you take that from traditional manufacturing, and then what you do is you go through the process loop, so you would add surface mount devices, so chips, resistors, LEDs to the outer surfaces. Then you print your circuitry, interconnect, so connect all of your electronic components together. And then you go through some post-processing. So we're dispensing and depositing or printing inks and paste. They're wet, they need processing. So you use light, you use heat, you use lasers, you use UV curing if necessary, depending on what the materials are. And basically what you get at the end of this process is a complete mechatronic system. So that's really the kind of state of the art, again, across a lot of different markets. So automotive is looking very promising now. Cell phones I already mentioned, industrial, some commercial aerospace, medical technology. So there are actually a lot of wide-ranging application fields for this technology. And then in the last couple...
Can I ask a question, Martin? It means that if you print on existing structures, it means that you need to have the CAD drawings or the design of the thing where you put on the 3D conductive material. So how is there a special software for that, or?
Yeah, so we have our own proprietary software called Motion 3D. So that's a fully functional CAD-CAM system whereby we've basically really focused on the CAM side of it to actually make the machine code and program that in an effective and simple way. So what we would typically do is start with a CAD file, a step file that can have the circuitry already in it and the SMD components in it. Or we can take 2D CAD files for circuit layouts and integrate those and wrap those onto the surfaces. And then from that, we go through a fairly simple routine, building up your print operations. When the operator is, or the program is happy with that, they can run simulations, then they can generate the G code, which basically then is sent to the machine and drives the manufacturing operation. So it is a digitally driven technology.
Okay. Okay.
Good. So as I was saying, we have ever since we started printed on existing structures, Now, what's becoming very interesting in the last couple of years is the concept of fully additive manufacture. So we'll actually just skip back there. And what we're doing there is we're working slightly differently. We're combining 3D printed electronics with classical 3D printing. So what we will do is we will build the mechanical structure. And as we're building the mechanical structure, we can place surface mount devices inside them. So you start building mechanical structure, add your surface mount devices inside them, and then print your circuitry inside, and then go through your post-processing, continue then to build your mechanical structure, and you can also then put your electronics on the outside. So basically what you will end up with is a fully additive generated component. And I have one slide here that shows an example. This was a project that we did in conjunction with FAPS. And it's a demo part, it's an egg timer. So you'll see the function of this when the video runs, hopefully. So basically we have touch sensors on the top. There are 20 LEDs outside that structure. And then we also have the electronics embedded inside. And basically, depending how long you want to cook your egg for, you program that so the lights flash, I think, for 15 seconds for each one. And when they go out, you'll see what happens. Obviously, the whole thing lights up, it flashes. You've also got an acoustic signal. So you should see that any second now.
Yeah.
Okay, your egg is ready. So, so again, it's just a demonstration part, but it's very interesting because if we look at the bottom here, stop that video. So basically you can see on the bottom left hand here, this is the 2D layout. So we have the LEDs, we have our circuitry planned. Then what we have, this is actually from our Motion 3D CAD CAM system. You can actually see the surface mount devices, so the LEDs around the outside. We have the acoustic signal comes from this buzzer that's embedded. The controller is embedded directly in the center, and you can see the red circuitry, so from the touch sensors and all the circuitry that runs through that. So something like 2 meters of circuitry within that component, and also on the outside. And here you can see in the bottom right-hand corner an X-ray image of that device. So you can see quite clearly the embedded controller directly in the center of the egg, plus the buzzer, and then you can see the LEDs and the circuitry throughout the rest of the structure.
So, which means that you are manufacturing 3D printed the plastic, then you add a component and you connect with the electronics. So it's
what we're doing
a parallel process.
So the mechanical structure is built using the FFF, fused filament fabrication process. So that's the yellow material. So that's the thermoplastic resin. We can also dispense materials. We'll do something similar on ceramic materials. So fully printing the electronic structure with ceramic substrates.
Okay, cool. So so you have two options: print on existing structures, or let's say create a structure in parallel and print their electronics. So what do you see that these two parallel roads will continue? Will they grow? What is your vision about what's going to happen?
Yeah, I think really the actual split will depend on the quantities that you need. So, for example, with the best will in the world, if you look at something like a cell phone application, you're not going to be 3D printing a mechanical body. You're going to rely on injection mold or some manufacturing technique that allows you to get the volumes of the substrate, because the actual mechanical build is the thing that takes the most time at the moment. So the fully additive electronics, that's going to be small series, quite low numbers. It really depends on obviously what the component is, but that's really one of the areas that we'll be focusing on in the next couple of years, is really how to speed that process so we can actually get some volume capability. I think the target really in the next few years will be able to get to kind of the range of maybe 10,000 parts, that kind of order of magnitude, using this fully additive route.
But the fully additive route gives also a lot of flexibility in design. I mean, traditionally you have a printed circuit board which is flat, and now you have the possibility to, let's say, make a printed circuit board which is 3-dimensional.
Yeah, correct. So I mean, design flexibility for 3D printed electronics anyway is a key thing. So you made a very important point there. You're effectively disposing of your 2D PCB, so you're not limited by working in 2D space. So you really can, even if you take an injection molded component, you can add intelligence to basically dumb molded components. So you can have your sensing, you can have your communication on that piece of plastic or ceramic or whatever that happens to be.
Okay.
You could, great. Obviously, it goes to an even higher level if you're starting to put your electronics inside, which you can do with a fully additive route as well as the outside.
Okay, well, thank you very much, Martin, for this explanation how you, what's going on 3D printing electronics world and what you're doing with your company. So thank you very much. And before we end, I always ask the personal question, which is, I would love to know a bit about the person behind the presenter. So what is your favorite music, your favorite art, book, food, whatever. So share this with us.
Food is a very good one. I like food. I generally tend towards sort of Asian style of cooking. So whether it's from the Indian subcontinent, Indian food or Asian food, it's really whether it's Thai or Szechuan cooking from China is fantastic. I like a little bit of spicy food, Indonesian, Malay, whatever. So that's also one of the nice things about being in the business that we're in, is that we also get to visit customers and travel and get to eat lots of very good food on that journey.
And probably you have a lot of customers in Asia.
Yeah.
Okay, well, thank you very much, and look forward to talk to you soon, and all the best with all your new project, additive manufacturing of 3D printed electronics. So thank you. Thank you.
Okay, thank you, Peter.